morning, friends. Today we are going to discuss sets. Since I have received some complaints regarding the videos uploaded by me on YouTube not being very clear, I am now experimenting with a slightly different tool. So let's see how it goes. So let us start discussing sets. You would find that the questions from sets, specifically from Venn diagrams, do appear in various competitive exams also, and that is why it is very important to know about the basic theory of sets. So we'll be starting with the theory and then we'll move on to application in the forthcoming lectures. So let us start. Let me tell you right in the beginning as to what sets are. Basically, sets are well-defined collection of objects. Now please see that well-defined has been written in bold. So the collection of objects is very well defined, such that there is no ambiguity. Then it would be called sets. And how do we denote sets? They are denoted using capital letters. Okay, we'll take up some example to understand this better. Now, a set of all vowels in English language. Now again, this is a well-defined collection of objects. Why is it well-defined? Because everybody knows what are vowels and how many vowels are there in the English language. So this is a well-defined collection of objects. And what are the various elements which would be part of this set? The various elements, there would be 5 elements in all: A, E, I, O, U. Is this okay? So this is an example of a set, but this is not how we write sets. The notations are slightly different. We'll discuss them also. But for now you should understand what sets are and what are the various elements in a particular set. Now again, let us take one more example. Set of all girls pursuing BBA from Government Degree College, Pithoragarh. So this is a set and a very well defined set. Why? Because everybody knows which all girls are pursuing BBA from Government Degree College, Pithoragarh. So that can be very well, there has to be no ambiguity while defining a set. Then only we can say that this set is very well defined. Now, what will be the elements in this particular set? You can find out on your own, and you can also find out the number of these elements which will be part of this particular set. Now another example is set of odd numbers. So what will be the elements? You know what odd numbers are: 1, 3, 5, 7, 9, 11, 13, 15, and this will go on till infinity. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, so on and so forth. So these are the various elements of this particular set. Again, this is a very well defined set. We know as to whether a particular number will belong to this set or not. For example, we'll know that the alphabet O is not going to be part of this particular set because the set is of odd numbers. Likewise, the number 4 is not going to be part of this particular set because 4 is an even number. So the point is that the set has to be very well defined. Now let us talk about the elements of a set. Objects which are included in a set, they are the elements of that particular set, and we denote them by small letters. Please bear this in mind. The set is denoted using the capital letter, while the elements of that particular set or of any set are denoted using the small letters. Another point which you have to take into account is that sequence of elements is not important. In which sequence the elements have been placed in the set is just not at all important. So this is one example. A is equal to A, E, I, O, U. The capital letter denotes the set A, while the small letters denote the different elements in this particular set: A, E, I, O, U. So naturally, capital A on the left, which has a tick mark on its left, is basically denoting the set, and small a, e, I, o, u are the elements of this particular set. So there are 5 elements, and we can now say that probably A is nothing but the set of all vowels in the English alphabet. Now then you can also see that the elements A, I, O, U, they have been shown to be equal to another group of elements I, O, A, E, U. What does this mean? This means this shows that the sequence in which the elements are placed in a set is not important. Again, one more thing that you have to keep in your mind is that elements of a set belong to that particular set. For example, we have seen that in the second line we saw that the capital A, which denoted the set, is equal to AIOU. So small a basically is an element of the set, and that is why it will belong to that set. So we have shown here, we have given the example A. Now this is the symbol for belongs to. So A belongs to A. Small a means the element in the set, while the capital A means the set. So small a, this element belongs to the set A shown by capital A, where A is this particular set. So remember this sign that we use to denote the relationship. Here small a belongs to A. So this is the sign that we will be using to denote the relationship. It looks like it looks like E. Now how do we represent sets? See, there are two ways of representing a set. The first one is called the roster tabular form and the other one is called the set builder form. Now what are the differences between the two? Let's talk about the roster or the tabular form first. Now what happens in the roster? You know what a roster is? It's a list of all the elements basically, and that is why we call this form the roster or the tabular form. Here all the elements of the set would be listed in this particular form. So if you represent your sets using the roster or the tabular form, then you'll have to write down all the elements in that particular set. And how do you write it down? You'll have to separate the elements using a comma, and then you have to enclose all the elements in the curly bracket. So this is the curly bracket. So all the elements of the set will be enclosed in curly brackets, while every single element would be separated using the comma. For example, now we have taken up this example, set of vowels. So set of vowels in the English alphabet, you know A, E, I, O, U. If you represent this using the roster or the tabular form, you will write it like this. You will enclose A, E, I, O, U. They have to be separated with a comma, and then you have to enclose all these elements in a curly bracket. So this is one example. Now where do you use tabular form or the roster form? You would understand that these are very suitable if these sets have only few elements, like the case here. There are only 5 elements in the set vowels. So whenever there are few elements, you can always make use of the tabular or the roster form. But if there are large number of elements, say 100 elements, 200, or maybe infinite number of elements, then the representation form that you will be using is the set builder form. Now what is the set builder form? It basically describes the common property of elements in set. So it does not list down all the elements of the set, which was the case with the roster or the tabular form. Rather, it describes one property which is common to all the elements in the set. Let's take an example. Set of vowels. How do we represent it in the set builder form? Now see, this is the representation. This one is the representation in the set builder form. A is equal to, curly brackets have started, and then we'll be ending also with curly brackets, and the colon sign that you see here, we will be terming it as such that. So I'm now going to read this particular notation. A is equal to x such that. Now such that is for the colon sign. So A is equal to x such that. X is a vowel in English alphabet. So x, all the elements, all the x's which are vowels in the English alphabet, they will be part of this set which is denoted by capital A. So you know all the vowels which are there in the English alphabet, A, E, I, O, U, and all of them would be part of this set which is denoted by capital A. So, and how do we say this? We say this like this: A is equal to X such that X is a vowel in English alphabets. So what we have basically done is we have described the common property of all the elements. And the common property is that they are all vowels in the English alphabet. Is this understood? So this is how you represent a particular set using the set builder form. Now naturally this particular form is going to be useful when you have got a set with very large number of elements. For example, let's take example of set of all the odd numbers 1, 3, 5, 7, 9, and all the odd numbers mean 1, 3, 5, 7, 9, 11, so on and so forth till infinity. So can you keep on writing till infinity? You would not be able to do that. In that case, roster tabular form is not what you are going to use. You would be using the set builder form, and you can always write A, or let's say B, is equal to X such that X is an odd number. So this is how you are going to use the set builder form here. Okay, so this was just the introductory lecture. We will be moving ahead. I'll be giving you a little bit of a flavor of the theory, and in the next video session we'll be discussing the various types of sets. Till then, please go through this particular video session well, and please go through all the contents. Thank you very much.